In this section, we want to look at graphing an exponential function. So one thing we need to remember from rational functions is about an asymptote. So remember, an asymptote is a boundary line where it's basically an imaginary line that the function is going to approach off to an infinity, but it can never cross or touch. The reason we need to remember this is because an exponential function also has an asymptote. Now, in a rational function, it had a vertical and a horizontal asymptote. However, in an exponential function, it only has a horizontal asymptote, all right? Now, when we look at the elements of an exponential function, let's first look at what it actually looks like for a second. So here we see a basic exponential function. So I want to look at a couple of the key elements here. So one thing that we'll notice is that it has this horizontal asymptote at 0. The way that we know that it's got this horizontal asymptote at 0, since the asymptote is not drawn, is because we notice that the graph is leveling off and it's going, and it's approaching that value of y equals 0 all the way off to infinity here. So that's one way we would know that it's got a horizontal asymptote. Another thing that we want to notice about this function is that it's got a domain of all real numbers. We know that because we see that it's going off to the left to negative infinity, and then as it goes to the right, it's going off to positive infinity. So my domain would be negative infinity to infinity, or all real numbers. The range of this function is going to be from that horizontal asymptote. So in our case, it would be from 0, which is the horizontal asymptote. It would be from 0 to infinity, okay? Because I can never be below 0. As you see, the graph would have to cross or touch, and we know that it can't since it's an asymptote. Right? So our range for this function that we see here would be 0 to infinity, right? Now, the next thing that we notice about this function in particular is that it's got a key point of 0, 1, right? So one of the key features of an exponential function is that it will always have the point 0, 1, and then 1, the base value. So if we knew what this function was, we would be able to tell what our base value is. Here I'm going to estimate a little bit. I think it's about 2 point something I can see here. So I would always have the ordered pair 0, 1, which we see, and then 1, the base. Now, if we think back to what an exponential equation looks like, or an exponent in general, we would always have a base number, and then we would have a variable in the exponent, all right? So that b in our equation represents the base of that function. Now, remember back whenever we were talking about how could a graph transform? Well, remember, we could move a graph up, down, right, left, stretch, shrink, reflect, do all of those things to it. So one thing that hopefully we notice is that I can see those same transformations here. Remember, our h is going to move it to the left or to the right. This k is going to move it up or down. And if I put a number in front of that base, then it would stretch, shrink. If I put a negative in front, then it would reflect. So all of those things that could happen to the functions that we looked at before can also happen to this exponential function. So we need to talk about how is that going to affect these key elements that we had in our basic function, right? So we already talked about b is going to represent that base value. The next thing we need to talk about is that horizontal asymptote. So in our example here, it was at 0. Now, if I were to take this function and move the entire function right or left, it's not going to do anything to the y values. It's going to affect my x values. And I notice that my x values are already negative infinity to infinity. So moving something right or left, in our case, the h, is not going to have any effect on our key elements. However, if we were to move this up or down, up and down is going to affect my y values, which would then affect that horizontal asymptote and the range. As we notice that y equals 0 became the number of our range. So this k value, or this up and down motion, is going to become the horizontal asymptote, and it's going to become what the range is doing. Okay. Another thing that could possibly affect that range is if we were to reflect our function. If we were to reflect our function, remember that comes when we have a negative in front. If we were to reflect it, then we notice instead of a positive infinity, we have a negative infinity for the range. Because if I were to reflect this graph, it would now be below that horizontal asymptote, right? The next thing that could happen when we start to transform things is this table of values is going to now change. So instead of having 0, 1, 1, the base number, we would move those points up, down, right, left, stretch, shrink, reflect, all right? So let's look at a few examples so we can see what's happening here. So let's say, for example, we have the function f of x equals 2x minus 1 plus 3. Right? So the first thing that we want to do is be able to come up with the different elements here. So we know for sure that the domain is going to be all real numbers, right? Because no matter what I do, I'm never going to change those infinities. However, my range is going to come from that horizontal asymptote, which comes from how do we move up or down. So let's see in our equation how we're going to move. So I see that we have a plus 3, which means we're going to be moving up 3. So if we are moving up 3, that means my horizontal asymptote is going to be y equals 3. There is no reflection here, so that means that my range is going to be 3 to infinity, right? If I had a negative out in front of that 2, then I would have said negative infinity to 3. All right, so I can tell all of those things just by looking at what is the number being added or subtracted at the end, and if there's a negative in front of my value. All right, so now that I have those things, let's see if we can come up with our table of values. All right, so I know before we begin, I start off with 0, 1, 1 in the base. So remember, our base is going to be this 2. So these are my original points. Let's see what happens when we move this to the right 1 and up 3. Okay, so if I were to move these points to the right 1, what that means that I would do is I would add 1 to all of my x values. So my new points are going to be 1 and 2. I'm adding 1 to each of those. Then if I'm going to move up 3, I'm going to add 3 to my y's, which means that I'm going to have 4 and 5. So my new ordered pairs are now 1, 4 and 2, 5. So let's go ahead and graph. When I graph, notice from my first example, I have 2 points here, and I have that horizontal asymptote. So let's get our 2 ordered pairs on there. We're going to put 1, 4 on there, and we're going to put 2, 5. Right? Then we're going to put our horizontal asymptote at y equals 3. I'm just going to put a dashed line. Okay. Now what I want to do is I'm going to connect the dots here. One side's going to go off to positive infinity. One side's going to go off to negative infinity, and it has to approach but never cross that horizontal asymptote. So that's what my new function would look like. So let's look at one more example to make sure that we really have an idea of what's happening here. So let's look at our next example. Let's say that we have f of x equals negative 4 to the x plus 2 minus 1. All right, so we're going to do each element because they might not always ask for me to go all the way to a graph. They might just want to know what is the domain, or maybe just what is the range. Maybe they only want to know about the asymptote. So I have to make sure that I can do each one of these elements by themselves, as well as working all the way until I get to the graph, right? So first thing I'm going to do is I'm going to state my domain, which is going to be negative infinity to infinity. Remember, that does not ever change. Then to get my range and my horizontal asymptote, I'm looking to see how do I move up or down. So I notice here that I'm going to move down 1, which means that my horizontal asymptote would be y equals negative 1. I notice that I've got a negative there, so since I reflect, I'm going to now have negative infinity to that negative 1. Okay, so I need to come up with my table of values. I start off 0, 1, 1 the base. Now the base is just the 4. A common mistake people will make is they'll accidentally put the negative. We'll deal with that here in a minute. Right? So once I've got my original points, now we want to transform them. So let's see. We're going to move to the left 2. So that means I'm going to subtract 2 from my x's. So now I'm going to have negative 2, and I'm going to have negative 1. For my y's, I'm going to reflect, so I'm going to make them negative, and then I'm going to go down 1, so minus 1. So make negative 1 minus a 1 is going to give me negative 2. Negative 4 minus a 1 is going to give me negative 5. So now I've got my ordered pairs. So let's go start graphing. I'm going to graph the point negative 2, 2. Oh, excuse me, negative 2, negative 2. I'm going to graph the point negative 1, negative 5. I'm going to graph my horizontal asymptote at y equals negative 1. And then I'm going to go connect the dots. One's going to go to positive infinity. One's going to go to negative infinity. And when I talk about that, I'm meaning to the right or to the left. Remember, it's a horizontal asymptote. So this time I'm going to go to the left. I'm going to approach that asymptote and to the right all the way down. Okay? Now, some people struggle with how do you know which one's going to approach the asymptote? It's literally whichever one is the closest. I know what the shape should look like. Once it's basically going to either increase or decrease, right? So this one I notice is going to kind of decrease because it was a negative out in front there. The last one was increasing because it had a positive out in front there, right? So think about that as well. So now I should be able to identify different elements from either the equation or from a graph. I should also be able to graph that exponential function from the equation by going through all the elements and then coming up with my new graph.